DevOps Success at RavenDB with Oren Eini, Part 1.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host. Make sure to check out www.azuredevops.show for past episodes and show notes. And we'll get through the announcements. .NET DevOps for Azure, my latest book, is available. You can pre-order the A-Press book on Amazon, and you can get the preview edition through the manufacturer at bit.ly/.NET DevOps book, and the ebook at bit.ly/.NET DevOps ebook. You spell out .NET, DOTNET. And also special offer for user group or conference leaders or anyone speaking at community events. For those in-person events, I'd love to send 2 copies of the print book for you to give away. And to request those, go to bit.ly/.NET DevOps book for community. And the Ignite conference is now sold out, but you can get on the waiting list. And I'll be one of the official conference reporters, one of the community reporters for the Ignite conference in Orlando, Florida. And so keep track of my Twitter at Jeffrey Palermo or my YouTube channel, youtube.com/Jeffrey Palermo for some reports leading up to it. And then during the conference, all of the content will be streamed live. And so check out that. And I'll be covering the developer topics. And so that'll be exciting. And also, hot off the presses, I'll be teaching another training course. And that'll be my .NET DevOps Bootcamp, and that's in Austin, Texas on September 30th, aimed at lead developers, team architects who want their teams to ship quickly and operate better. And so watch for that announcement to go out on my Twitter feed at Jeffrey Palermo if you or your team want to get trained up. So now let's get on to our topic. My guest today is Oren Eini, and he also goes by the pseudonym Ayende Rahien. He's a frequent blogger at ayende.com, AYENDE.com, has over 20 years of experience in the development world, and strongly focuses on the Microsoft and .NET ecosystem. Oren has been recognized and awarded Microsoft's Most Valuable Professional Award since 2007, and he's an internationally acclaimed presenter appearing at DevTeach, JAOO, which is now the GOTO conference, QCon, Oredev, NDC, the JAOO conference, and progressive.NET conferences, sharing his knowledge via conferences and written work, such as a book, DSLs in Boo, Domain-Specific Languages in .NET, which is published by Manning, and now another book, Inside RavenDB. And he remains dedicated and focused on architecture and best practices that promote quality software and zero friction development. And he's also the founder and CEO of RavenDB. And we're going to dive into that today. Oren, welcome to the show. Glad to have you.
Thank you for having me.
Awesome. And you and I have been friends since, 2006, 2007?
Something like that, yes. Since I think there used to be alt.NET, think around that time frame.
Yeah, absolutely. Fun time. That alt.NET movement, man. And now open source and is kind of the normal, but it wasn't then.
I remember having to use Reflector to figure out what's going on inside the framework and then just dealing with the bugs.
Right.
I don't know if people understand the difference, but today, if there is a bug, I go not because I'm an MVP, not because I have some secret bug challenge. I go to GitHub, I open an issue, I tell, here is what I found, here is what I tried, and I get someone from the core Microsoft.NET team to look at this. And sometimes we report real bugs. Oh, I have a GC hole, a JIT error, those sorts of things. Sometimes they tell me, oh, you're doing something wrong, or you look at all things, but that's amazing. There used to be a bug. No one really cares about it in the SSL negotiation between Windows and Linux. The bug related to the fact that Windows 7, Windows 8 had a different negotiation strategy on Linux. I assumed at the time the code was written, the SSL negotiation matched the Windows 7 behavior, not the Windows 8 behavior. That causes blah, blah, blah issues. Now, this is the kind of thing that is super small and annoying for me, because I run into that, and no one else probably ever care about that. Mm-hmm. I was able to submit a patch, got review from the people who actually maintain the product and understand, you also need to consider this and this and this and that, and it got accepted. And I have quite a few stories like that. Now, the reason this is impressive, and sometimes I look at the mirror and says, did this really just happen? Is let's go to 2005, Microsoft Connect. And Microsoft Connect was where bugs went to die. There used to be an awesome bug there. If the .NET has a set of classes that convert from one type to another. Now, there used to be a method that said can convert. And can convert from a string puppy to Boolean, it would say yes, and then throw an exception when you actually try to do the conversion.
Yeah, these are really nascent bugs.
Yeah, but try to imagine, I have two methods, can convert from string to bool, and you're giving the specific string, and convert from string to bool after you validate that, and then it fails. That bug was reported. I remember it being alive for like 5 years or so. Eventually closed as won't fix. Why won't it be fixed? For backward compatibility concerns.
Right. Yeah, there's a lot of stories like that.
Yeah.
But blast from the past, for those who maybe got into the industry after that time frame, the AltNetConf Google group is still there. The archives of messages are still there online if anyone wants to go and kind of look at the history of that movement. What's so interesting is that Scott Guthrie himself came to Austin, Texas, and was at that conference, and so he participated in that community, and now he's running Azure. And so, it's really interesting to go back through the archives. You can go to the URL for listeners, groups.yahoo.com/group/altnetconf. That's ALTNETCONF. And kind of, if you want to look back at some of those conversations, if you weren't a part of that.
It's funny because you can, you just from the URL, it's an old one because it uses Yahoo.
That's exactly right.
Yeah. And actually looking back at that, it's been 12, 13 years since the start of the .NET movement. And in pretty much every respect, everything that we cared about at that time frame happened.
Yes.
And it's just amazing. I remember looking at it and being sometimes it was like so frustrating. It's like, just give me half an inch. That's all.
The movement succeeded. So it succeeded, but dare I say, we succeeded. And by we, many, many, many people who were a part of that community and a part of that movement. So that's all. So how did you come to RavenDB? Now, fast forward, what was the trajectory, and why the heck did you go through all the effort to start a company?
Okay. So in 2004, I wanted to learn big code bases, want to learn about production systems. So I started reading through the NHibernate code base. I started working with NHibernate. NHibernate, to those of you who aren't aware, is an object-relational mapper. It's if today you would reach to the entity framework, then NHibernate was there at the beginning of the 2000s. And get more experience, get more knowledge. And I decided that I want to go to big, interesting code bases. I ran into the NHibernate project. NHibernate is an object-relational mapper. If you're not familiar with that, it's entity framework is similar to NHibernate. And NHibernate has been around since the early 2000s. And fascinating code base, has the backbone of many systems. And since 2004, I was very involved with that, and I built quite a lot of applications, both directly as me as the part of the team or for clients consulting. At some point in 2008, I actually became a consultant and went around between different clients, helping them improve the performance of the application. And it got to the point where I would come in and I would typically spend a week or two at the customer site, and I would always give them the exact same story. Okay, you have a select N+1. You are making 10,000 queries to load this page. 10,000 was rare, but hundreds wasn't rare, unfortunately.
Well, let's talk about that for people who are maybe new to object-relational mappers and select N+1, because that's a big issue. But
people don't realize that. So let's take I think the simplest example I can think of. Try to imagine that you have a customer page, and in the customer page you want to show the list of orders.
Mm-hmm.
Perfect. Okay, so you do a select star from orders where customer ID equal X. Perfect. Now you also want to show what is the total amount of records for total amount of this order, but that isn't stored in the order table. That's stored in the aggregation of the aggregation of the order lines. And if you want to show, here are your favorite products based on your orders and a bunch of other stuff like that, and suddenly you end up having something really interesting. You have, first query, let me get all of the orders for a company, and let's say I'm getting 20 of them. Now, for each one of them, let's grab all of the lines and compute the total. Now, and in some cases also for each line, go and grab the associated product.
Mm-hmm.
If you weren't careful about doing that, it's possible you get one query to get 20 orders, 20 queries to get 20 order lines for each order, for each of the 20 orders, and then even more queries just to load the products for those lines. And now you made something that is trivial and simple. Give me all of the orders for a company, or just give me the recent orders for a customer. And now you generate hundreds of queries to the database. Now, the kicker here is that you generally don't notice that.
On your own box. Yeah.
Yes.
It's fast.
Because on your own box, you typically don't have 50 orders for a customer. You have 1, 2, 3, stuff like that.
Mm-hmm.
You have 1, 2, 3 items in there. You also in each order. You also have the database and the application sitting on the same server, so there is no network latency. You also have just a single active user. Now let's move into production, where you have a database on one box, server and the web app on another box. You have users that have hundreds or thousands of orders. Each order, and a good example, if you go to the grocery store, then you might have an order that has 100, 200 items. And now you load, let's load my 20 recent orders. Each one of them has 200 items. Well, say goodbye to your system, especially when you have multiple people using that at the same time. So I typically went, and now the problem here, and the thing that kills me, is that in many cases, it's not a hard problem to solve.
If you know about it.
Yes, and if you know how to fix that. And sometimes some of the things that people did, they built layer on layers on layers of abstractions. So if you're using the MVC system, at the controller level, you call a service, that call another service, that call a repository, that call an abstract factory garden or whatever, and eventually you end up with some SQL being generated. And when you needed to actually do something about it, you had to go through all of these layers, or you could just get an axe and chop them.
Yeah.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
And it could be simple code. It's a collection.count. And then because of lazy loading under the covers, you get hundreds of queries.
Yes, especially, another fun thing, sometimes people would send live operations to the view. So if let's assume that you have ASPX, and I know that probably modern people won't even know what an SPX is, but this is basically a templating language like PHP.
Well,
but you get
10 years ago, it was state of the art still.
Yeah. But then you get effectively a designer that write for loops and stuff like that on an object that is connected to a database. So in many cases, you would take an older object and push that into the view. And then the view would decide based on your object model what to load. And then based on that, which is insane, you would get queries being generated. And now if you wanted to optimize that, you had to optimize that in the controller based on what the view needs to handle. And all of that with lazy loading meant that you got really, really speedy development time, because let me grab the object, let me just push it to the view, and let's just render it. And it worked, but it had horrible performance. And my issue was that I wasn't dealing with stupid people. That was the crazy.
And you were
things.
consulting, so you're consulting on performance.
Yeah, and I kept coming to customers, and in many cases they knew what the problem was, but they didn't have any idea how they can dig themselves out. In one case, I spent 2 weeks refactoring the system, and pretty much because no one else was, everyone there was too scared to touch a particular piece of system, and I changed it from taking 40 seconds to do a common UI operation to taking 5 milliseconds.
Yeah.
And it's just, I had to work for 2 weeks to make 3 lines of code of change and actually make it stick. And that was really, really frustrating, because the problem was the environment led you in a particular direction, and then you dropped into a horrible pit of nasty and subtle performance issues.
So it sounds like that burned you out a little bit. That helped you decide to, hey, I'm going to create a company.
Yeah, no, actually I didn't. What it made me want to do, it made me dream about a database that wouldn't lead you astray, that would make it easier for you to actually get things done. So I started looking at NoSQL databases. And remember, the time is 2007, 2008, and there are NoSQL databases there, and you could use them. It was basically juggling knives while riding a unicycle, while singing, I don't know.
You're on your own.
Yeah. And there used to be a great comics that says, how do I query the database? All you need to do is write a distributed MapReduce function in Erlang. And I'm not going to do that. So I started building, I actually didn't start building, I started designing in my head how to build a database. And the problem was that it really started rolling from there, and I couldn't get it off my hand, to the point where I distinctly remember at one point at 2 a.m. I woke up and I'm looking at the ceiling and I'm seeing different components tying themselves together as, okay, this is how I'm going to do the indexing pipeline, and a bunch of other stuff like that. And just eventually I decided, okay, let me just write the code. Let me just make sure that I get it out of my head. And the intent was to spend, a weekend or two on that. No, I actually had, paid work to do. But I started working on that. And then at some point, I realized that it's been 3 months and I have something in my hand that, I can actually work.
Well, let me add some context to this, because you're uniquely positioned for this. You had become at that time, I guess, an expert in a handful of major databases, because you were a prolific committer and maintainer for NHibernate, which got really, really deeply connected to not just SQL Server, but a number of database providers. So you had become an expert in what it meant to be a database.
No, I become an expert in being in what it means to talk to a database, which is subtle but very important difference. So here is a really common scenario. Let's go back to, I want to get the orders and the order lines, or something like that. So in a relational database, there are a few ways you can do that. You can do that using a join. You can do that using correlated subqueries, a whole bunch of other stuff like that. The problem is that a join means that you change the shape of the data, you get into Cartesian product cell, stuff like that. With RavenDB, the concept of, I'm going to load a record and I want to get a related record is something that is a fourth-line concept. We call it includes, and you can say, give me this employee and also give me its manager, or its manager, all bunch of stuff like that. That doesn't change the shape of the object. It doesn't change the amount of data that goes on the wire unnecessarily. All of that. RavenDB has a feature for something called lazy operations. And lazy operations, let's say that, again, coming back to the orders page, you need to have a query to render the customer details, get me the number of orders that it has, get me the recent orders, all bunch of stuff like that. Each one of them you would typically run as a separate query. With in SQL Server, sometimes you can do that through something called MARS, multiple active result set. And sometimes you can do that by sending a set of queries concatenated with a semicolon, all of which have very serious issues. For example, the number of parameters that you send are limited, and a bunch of other stuff like that. RavenDB has lazy operation as a concept that, okay, let me gather up all of the queries that you want, and then send them all as a single request to the server, and now you saved a lot on round trip. And with modern databases, especially if you're not heavily loaded, a major part of your performance is actually going to be the cost of actually going to the database. And ideally, in most cases, if you have a read operation, you typically are able to go to the database once using features such lazy, includes, stuff like that. You get everything that you want in one trip to the database, and that's amazing. Now, the other side here, let's talk about caching. And NHibernate, for example, has 2 or 3 levels of caching, and I used to have workshop on NHibernate, and caching was a 2 hours topic. It was that important, that complex, and for certain values you could get caching to really save you or absolutely kill your performance. There was a couple of cases where I actually got called and, we are using best practice caching and stuff like that. And because they were using caching, the system performance was horrible. So RavenDB has caching at the protocol level. If, again, going back to the customer, a customer typically don't have too many orders, too much traffic on these orders. So you make a query on a customer orders, and the client is going to cache that value. The next time that you're going to go to this customer's order page, you're going to issue the same set of requests.
Yeah,
they're going to go to the server, and then you have a dedicated code path specifically to check whatever the value that you have in your in-memory cache is valid or not. And if so, it's okay. Use whatever you have there. And that saves you a lot of network traffic, saves the server from doing any sort of processing. You can extend that even further by saying, you know what? Instead of every time that the user goes to the page, I need to go and ask the server, has something changed? I can reverse the flow. I can say, you know what? I'm going to serve everything from the cache that I have locally, but I'm going to tell the server, let me know when this changes. And then you get this, you get even further. And there are lots of stuff like that was the core of RavenDB, the core of the things that we did. Here is another.
Okay. Well, let's get into the DevOps portion of it. You built a database product, and so you've built a DevOps environment for this product, and it's working great. And I think the listeners would love to kind of hear, how the heck do you do that for RavenDB?
Okay, so the first thing to understand is that when we started RavenDB, we focus on the development experience, on the performance, stuff like that. As time went by, people deployed us in all sorts of interesting configuration, and support and visibility to what's going on became more and more critical. Now, something that I decided to do very early on was how to treat support. So almost from the get-go, I was involved in many of the support requests. And if I'm not handling a support request, then it typically go to the seniorest people in the company. The logic is very simple. I don't want to have support issues. The best way to do that is to make people see what are the common support issues and then fix them. Alongside with that, we don't consider support to be our business model. So RavenDB is an open source model, open source database. There are all sorts of business model around that. One of them is to charge for support. I think that a project that charge for support typically have a perverse incentive. You might want to have more features, more performance, stuff like that, but if you make it too easy to use, no one will pay you. So with RavenDB, we explicitly consider the support to be a cost center. So it's something that costs us money, not make us money, and we try to reduce a lot of the operational overhead on that. Now, just by the fact that RavenDB is written in a managed language, you get quite a lot of information out of the box. Things like performance counters, things like visibility into stack traces that is amazing. But by default, you build an application, you push it to production, and it's a black box. Now, if you're good with debugging, there are all sorts of tools that you can use. There is a WMI on Windows. There is the perf counters, system tools, process explorer, those sort of things. You can use WinDBG. There's a tremendous number of tools. All of them can give you valuable information if you spend a lot of time on that. And what we ended up doing is to say, okay, after we, for example, let's say that you're running into, and we used to have issues with memory fragmentation and long GC parsers. So one of the things that we have done was to build directly into RavenDB memory reporting capabilities. Now, we could get that from the GC, we could get that from the operating system, but right now I can go to a RavenDB instance and ask it, okay, show me your memory utilization based on task and thread activity. Internally inside RavenDB, we have features that are meant specifically for the debugger to take advantage of them. We expose a lot of state using SNMP. We have created a dashboard for RavenDB that tracks what's going on. Now, let me give you a really something that killed our support team time and time again. If you have an error, you can typically figure out what's going on. Error is obvious, it makes sense, stuff like that. What happens if you're slow? And if your consistency is so great, I can figure out what's going on. What happens if the issue is that you have a customer that tells you, oh, I have an issue with my 99 percentile. All of my queries ends within single-digit milliseconds. I have one query in 100, one query in 1,000 that takes a second or two. And trying to figure that one out.
Yeah, how do you isolate that?
Yeah, especially it used to be the case that you can plug just Fiddler into the stream and see what's going on. But now we are considered the system to be running in a hostile environment, also something that for DevOps. So everything is encrypted. So you can't even sniff the network. So right now, if you can go into RavenDB instance and ask it, okay, show me the traces of all of the requests that's going on. Show me, I see that this request took a lot of time. What was it doing? This is a query. What was the query? What were the arguments? All sort of other stuff that we always keep. Now, this is something almost ridiculous. We typically have, I think that over 30 or 40% of our effort was spent on that. So we spent a lot of time building the core, the foundation, and even then, a lot of the design principles, a lot of the things that we have done were made explicitly, okay, how do I enable visibility and debugging into what's going on here? So in the case of the slowness, let's say that you're running on AWS and you just, I'm setting up a new machine, throwing RavenDB there and starting testing out, everything works. If you haven't done something special, you're going to run on a GP2 drive. GP2 drive is a burstable I/O. It has some number of IOPS based on the size of the disk that you have, but you also have burstable up to 3,000 IOPS, which is great, wonderful. Now you start using the system and you have some capacity on the burst capacity, and you start going through this capacity, and then you hit the limit, and now you're suddenly being throttled. You move from being able to do 3,000 IO operations per second to being able to do 100. And that sometimes go away because, I have a spike. 9 a.m. users log in, I run to the spike, and then everything comes down and performance comes back. So RavenDB will monitor all of the actual I/O operation that it makes. And there's actually a timeline view that you can look at. It says, here are all of the things that happen in this time frame. And here is the amount of data that we wrote, here's the latency that we wrote, also stuff like that. If you hit something with a certain threshold, then we're actually going to give you an active alert on that. And now you don't have to guess. Another good example, let's say that you're running on, again, burstable instances is lots of fun because it's literally performance that someone yanks the carpet from under you. But I also had that with Sun systems that storage that network that had quality of service settings that were flaky or flat out bad for us. And the Exchange server on this thing got all of the IOPS, and RavenDB got whatever remains up to a certain limit. So if someone just sent, and this was like, you try to figure out what's going on, then you understand that whenever someone sent a company-wide message, RavenDB will become slow. And the funny thing, in this case, they had they sent a company-wide message that told them go and hit this thing that was using RavenDB in backend, and everything basically ground to a halt because we didn't have any spare capacity. Another thing that we do, if you're running on a T3, or I think in Azure it's the B series, T3 on AWS, then you have a set number of CPU credits.
Mm-hmm.
You can tell everybody, oh, I'm running on this kind of instance, and then it would monitor its own CPU usage. And if you're about to hit the limits, it's going to start it's going to start blocking certain background operations, and then it's going to start just blocking access entirely. With the idea here is that if I'm running on a cluster, and I have 3 nodes in a cluster, for example, then I have one node that is very active, and it burned through all of its CPU credits. If I'm not going to take any sort of active action, then the system is going to effectively freeze. I'm making a request to you, and you will reply to that. But maybe you reply to that in a few seconds, and that's very visible to the rest of the system.
This is such a great topic, and we dove in really deep with Oren on this interview, and it goes on for some time to come. So we are going to split this into a part 1 and part 2, and the second part will be available next week. And so until then, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.